Today we're going to be doing a cellular respiration lab using yeast, and we're going to be using it in various types of bread dough so that we can see how much the bread dough rises at each of these 4 different temperatures. We are going to have a control with no yeast in it, but at its preferred temperature of 105 degrees Fahrenheit or 40.5 degrees Celsius. We'll have another one with yeast at the same temperature. We'll have one in an ice bath and one at room temperature, which in my house is a toasty 64 degrees or 17.8 degrees centigrade. For this experiment, we're using bread because the gluten in the bread flour will trap the carbon dioxide given off by the yeast, causing the bread dough to rise. For this experiment, not only will I need to use the measuring cups that we saw earlier, but I'll also need a scale, yeast, salt, water, and flour. I'm going to mix these all together, but first I'm going to do this without the yeast added in order to make the control. To make the control, first I mixed water, salt, and flour together, and then I'm going to put this on the mixer in order to make it look like bread without the yeast. On the scale, once I filled the container for the control that contains flour, water, and salt together, it weighs a total of 128 grams. When I look, I can see that it is a little over 1/3 of a cup, or about 3.5 ounces. Now we're going to combine the water, flour, salt, and yeast together and mix it up in order to make bread dough containing yeast, which hopefully will cause our dough to rise. So here I'm putting the water in the container. I then go ahead and I take the flour. I add it all together. I'm going to add the salt, as well as the yeast. Now, typically you would add the yeast and the water together and let it sit for a few minutes until it is bubbly looking. And that's to make sure the yeast is still alive. I do know that this yeast is alive though, so we're going for the easy, quick method. The rest of the dough is now ready to fill in the containers. I'm going to go, and you can see I've already placed one container onto the scale. I'm going to hit on and let that tare. It should end up being 0 grams, which we can see right there. I'm then going to scoop in 128 grams of dough into this container. So in order to match what we saw with the control, you can see here I have 128 grams, and although the dough got a little mixed up, it will settle down and will be approximately the same amount as we saw in the first container. Now I'm going to fill the other 2 containers with dough at 128 grams. And then as you can see with the controlled, I will be covering each one of them with a layer of saran wrap. So we covered each one of these containers with saran wrap because you want to make sure that the top of this bread dough does not dry out. If it does, it won't be able to rise anymore. And as we are looking at the volume of the bread dough at the end of this experiment, we want to make sure that it has plenty of opportunity to rise. Both the control with no yeast and the dough with yeast at 105 degrees Fahrenheit, 40.5 degrees Celsius, are being heated up in my oven. The room temperature yeast is staying on my countertop. The dough in the ice bath is actually in snow on my back porch. And as we look at this, remember to come up with your hypothesis, determining which bread dough you think will rise the best which one you will think will do the worst, and the two in the middle. You want to rank these 1 to 4. 1 being the worst, 4 being the best. An hour has passed. It is now time to compare our 4 samples. You can see that I did take the saran wrap off so that we can get a better idea of what's happening. The first 2 that we are observing here is the control and the one that was in the same temperature, a little bit above room temperature at 105 degrees Fahrenheit. And you can see that the control, which had no yeast, is still close to 4 ounces. There's no bubbles. It hasn't risen at all. No CO2 has been produced in this bread dough, causing it to rise. In contrast, when I look at the same situation in the oven at 105 degrees Fahrenheit, but with yeast, you can see we're at about 11 ounces in height. And when I start to look closely, I can actually see that there are bubbles. The next container we'll look at is the room temperature container at a toasty 64 degrees Fahrenheit. When I rotate the container, I can see that the bread dough did indeed rise. Instead of being at just under 4 ounces of bread dough, we're now at about 6 ounces of bread dough. And you can see a number of bubbles formed on the side of the bread, on the surface. The last file I wanted you to look at was the ice bath. This one was outside, buried in snow for an hour. When I change it to the side, we can see that even though it had yeast, it really didn't rise much. The bread dough is still at under 4 ounces. As I pan across the 4 different samples, I can first see the bread dough that was in the ice bath. I can then see the one that was at room temperature. I can then see the control version that had no yeast, as well as the one at optimal temperature with yeast. Just for fun, I'm going to let these sit out on the counter for another hour, and we'll see if the one in the ice bath starts to rise. After an hour at room temperature, we can see that the ice bath has increased in volume. It's gone from just under 4 ounces to 6 ounces. When we look at the one that was at room temperature, it's almost reached the point where we saw the one in the oven after an hour. Now, when we look at the one that had been in the oven with the yeast, we'll see that it's actually collapsed down. And this is actually what happens with bread dough. When you hear recipes saying that after a certain amount of time, it'll flatten and level out. That's what this one has done. And of course, our control that was at 105 degrees Fahrenheit has done nothing.